So I just went back to our table so we can look at all our geometries. And I want to think about every one of them and think about, would it be polar or non-polar? Okay? So if I know what the geometry is, I can kind of predict what the polarity is going to be. So the first one is linear. So here's an example here. So this is just like the one we did earlier with CO2. So the oxygen's going to pull, this oxygen's going to pull. So if they're both pulling, is the carbon going to move? Yes or no? So the carbon's not going to move. So if it doesn't move, so not moving, non-polar. So if there's not moving, non-polar. So if it is linear, this is going to be non-polar. Now, here's the caveat. This is only true if both of these elements are the same. So if they're not the same, then it goes from non-polar to polar. Okay? So make sure you write that down. Anything that's non-polar that we write, if their elements are not all the same, then it's automatically going to be polar. Okay? All right, let's look at this guy. Now think about the three-dimensional structure, okay? When you write it here, you think, okay, fluorine's pulling, fluorine's pulling, fluorine. So if you draw like this, you think these two fluorines are going to pull, but nothing cancels this guy. But remember, this isn't the three-dimensional shape. This is what it looks like in a three-dimensional shape. So this guy's pulling, but these two pull at an angle. So all three of them are kind of around the central atom, all pulling at the same. So what happens is, because they're at angles, they all pull and nothing happens to the boron. He doesn't move. So if he doesn't move, this guy is going to be non-polar. The only way he becomes polar is if I change one of these three elements. All right, let's do the next one. So sulfur's got two oxygens on. So remember, this is that bent. So if this oxygen pulls, they're both pulling. So what's going to happen? If I both pull on something like this angle, they both pull, this guy's going to end up going down. So if he moves, if this central atom moves, then that means he's what? He's polar. So if it's bent, he's going to be polar. It doesn't matter if these are the same or not. See how these were the same elements? Because it's at an angle, it didn't matter that these two were pulling the exact same. Because there's an angle, it ends up not being able to cancel. All right, let's do the next one. So for this one, it's actually kind of easier to see it when it's drawn out like this. So you've got the hydrogen up top and the three at the bottom. So you think one up top, three at the bottom. How does that work? But these three, remember, aren't directly down. They're not pulling straight down. They're pulling at an angle. So when you're pulled at an angle like that, you're not getting as much of your force. So when you see it like this, it actually kind of helps you see this structure better. Because this hydrogen and this hydrogen kind of cancel, and this one and this kind of cancel. So this hydrogen is canceled by these three, and it takes three of them because they're at angles. So what happens is, when they all pull, this carbon does not move. So if he doesn't move, that means that they're all going to be non-polar. Okay? And it's non-polar assuming all of these are the same element. All right, let's look at this guy. So these are all three at an angle. So if they're all three at an angle, think about there's three of them and they're at an angle. Is my nitrogen going to move? Yes. So he's going to move. So if he moves, what is he? He's going to be polar. All right. If this bent was polar, what's the difference between these two bents? The only difference is the angle, right? And this one is kind of pulling like this. This one is pulling like this. So it's a more severe angle. So if I'm pulling, this central atom is going to move because I'm pulling this way, so it's kind of going like this downward motion. So if my central atom moves, then that means that this molecule is going to be polar. All right, let's do the other ones. All right, this guy and this guy, they're going to cancel. The middle is the same thing as my trigonal planar. Remember, these three are like trigonal planar. So if the three in the middle are trigonal planar, and the one up top and the one up bottom are are linear, then what is the polarity? Okay, so this is trigonal planar, which we said, because they all pull the same force, that it's nonpolar. The top pulls, the bottom pulls, so this guy doesn't go anywhere, so he is nonpolar. That's only assuming that it's all of the same elements. All right, let's look at this guy. So he pulls, they kind of cancel. Remember, these two aren't exactly like this. They're actually kind of down a little bit. So these aren't just like straight like this. It's actually kind of like inward a little bit. But even if we ignore that and we just look at these two, who's canceling this out? There's nobody over here to cancel it out like this guy was. Okay? So there's no one to cancel this out. So this guy, he's going to move. So if he moves, what is he? He's polar. All right, T-shaped. This guy pulls, this guy pulls. Remember, T-shaped is a droopy T. He's a sad T. So these don't actually fully cancel out, okay? But really, no one cancels out this guy. If he's pulling, this guy's gonna move. So if he moves, this whole thing is going to be polar. All right, this one is linear. We already talked about linear. He pulls, they're both pulling, so it's gonna cancel out. And so if it cancels out, that means he doesn't go anywhere. And so if he does not move, he is non-polar. Unless I change these two elements so that they're not the same, it's gonna be non-polar. Non-polar. All right, let's do the next one, octahedral. So this guy's on top, this guy's on bottom. So they both pull, they cancel each other out. These two are across from each other, because remember this kind of makes like a, down, there. So it's like, it's kind of hard to draw. Oh, it's like this. Here you go. Okay. So this guy pulls and this guy pulls, so they cancel. This guy pulls on the exact same amount on the opposite side. So if these two cancel, these two cancel, these two cancel, everybody cancels, so does the central atom move? Nope. So if he doesn't move, what is it? It's non-polar. The only way this is polar is if one of these elements is not the same. All right, let's do this one. So these two, remember they're not exactly across from each other. Because there's a lone pair right here, these guys kind of get pushed up a little bit. So they don't exactly completely cancel out going across. But there's nothing to cancel out this guy, because there's no other bond pulling. So that means there's nothing to cancel him out. So that means when he pulls, he's going to move. So if he pulls and he moves, if you move, what are you? Polar. All right, last one, square planar. So this one is just like this without the top and the bottom. So this guy and this guy are directly across from each other. So these two are going to cancel. This guy and this guy are directly across from each other. So they're going to cancel. So if these cancel and these cancel, everybody cancels out. Does he move? Nope. So that means he's non-polar. So all the ones that say non-polar won't be non-polar unless you change the atoms attached to not be all the same. So let's look at some trends. So our parent groups, remember all of our parent groups, parent group, you notice these are all non-polar. Parent group, parent group, parent group. Parent group, parent group are non-polar. All the structures that have lone pair electrons on the central atom are polar except for, so he's got lone pairs, he's polar. He has 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 lone pairs, he's polar. Here's one exception. He has lone pairs, he's polar. He has lone pairs, he's non-polar. So the only two that have lone pairs on the central atom that are non-polar are my linear and my square planar. Okay? All the other ones with lone pairs on the central atom become polar. So now that we kind of gone through our chart and our table and looked at all the geometries, If you draw the structure and you know what the geometry is, then you can also predict the polarity just based on the rules we just talked about, okay? So on the next lecture, we're gonna do a practice problem with that.